Good afternoon, students. So you're going to be working on this packet. It's not really a packet per se, it's got 2 pages. There are some solutions on the back page that you can check as you go along to make sure that you're doing the problems correctly. Please remember that you must show your work for credit and that there will be a quiz tomorrow. And so I would like you to be prepared for it by doing this homework assignment. On the second page of the packet, you'll see some solutions for Friday's homework. So you can check your solutions for Friday's homework. Hold on to that homework, and tomorrow we'll try to go over any questions you might have on Friday's homework, and also any questions you might have on this homework. We'll try to go over that tomorrow. So I'm going to go ahead and do the odds and leave the evens for you. So something that you might want to do is watch how I do it, and then pause the video and you do number 2. And after you're done trying it, you can double check your answers in the back. I believe most of them are accurate. And then you can move on to number 3 and watch me do number 3. I will do the odds and you can do the evens. Okay, so I'm going to go ahead and get started. Number 1, well, first of all, the directions say solve each equation by factoring. Now, number 1, 2, 3, and 4 are already factored, so we're just going to use the zero product property and set each factor equal to 0, and so that we'll know what values for x will make this equation be 0. So 8x minus 3 equal to 0. Well, I add 3 to both sides, so I get 8x equals 3. And then I divide both sides by 8, and so x equals 3/8. So that's one solution that will make this equation become 0. And then if I add 5 to both sides, I get x equals 5. There are the 2 solutions for number 1 that will make this equation, if we were to multiply this out and put these values in, it will make this equation 0. So now you can pause it and do number 2, where you set each factor equal to 0 if you want to. Okay, number 3, this equation has already been factored, and so I can set x equal to 0 and 8x plus 7 equal to 0. Well, x equal to 0 just means that one of the solutions is 0. And now I can solve for this one by subtracting 7 from both sides, dividing both sides by 8, and I get x equals negative 7/8. So the 2 solutions are 0 when x equals 0 and when x equals negative 7/8. Now you can pause if you like and do this problem. Number 5. Number 5 needs to be factored. It's not factored. I have a minus here without parentheses, and it's just not in factored form. Now this I can factor by using the greatest common factor. So I'm going to factor out an x, and I get x 7. Just 1 second. I'm going to charge my computer. 7x minus 3 equals 0. I just took out the greatest common factor, and what's left is 7x minus 3. Well, I set each factor equal to 0, and then solve. So when x equals 0, well, that's one solution. And then 7x minus 3, when that equals 0, I'll solve by adding 3 to both sides, and then dividing both sides by 7, so x equals 3/7. And that's the solution for number 5, and you can do the same thing for number 6. Number 7. Now this is a trinomial, and it's quadratic. I'm going to use the diamond here. So I have 12 up here, a times c, and then 7 down here. To solve this, I need 2 numbers that multiply to 12, but add to 7. 4 and 3. Okay, so because this leading coefficient is 1, I can just take the factors directly from the diamond. And now it's factored, and it looks a lot like the ones that are up here. And once it's factored, I can just set each factor equal to 0. So x plus 4 equal to 0, which means that x equals negative 4, and x plus 3 equals 0, which means that x equals negative 3. And those are the 2 solutions for number 7. Now number 8, you'll do the same thing. You'll make your diamond. Number 9, I'm going to make a diamond again. And in the top of the diamond goes negative 20. In the bottom goes negative 8. So I'm going to put negative 10 and 2 in to solve that diamond. I'm going to need to factor by grouping because the leading coefficient is not 1. So I rewrite the first term, and then I'll put negative 10x plus 2x into the middle to replace negative 8x. Then I rewrite the last term, negative 4 equals 0. Now I can factor by grouping, and I get 5x as a common factor times x minus 2 plus 2 times x minus 2. Take out the 2. So now I have what I need here, common binomials. I'll take out the x minus 2, and I'm left with 5x plus 2, and that all equals 0. Well, then I need to set each factor. Now it's factored. Great. It's in factored form. I set each factor equal to 0. So when x minus 2 equals 0, that means, well, I add 2 to both sides. So x equals 2. And then for 5x plus 2 equals 0, I set that equal to 0 and solve by subtracting both sides by 2 and then dividing both sides by 5. So my solutions are x equals 2 and x equals negative 2/5. And those are the two solutions for number 9. And number 10 will require the same thing, a diamond, but factoring by grouping. Okay, number 11. Solve each equation with the quadratic formula unless it can be factored. Well, here's the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So make sure you write that down somewhere. Now, can this first equation be factored? It's a quadratic. Can I factor this? Well, let's see. Negative 6 goes up here and 3 goes down here. Are there two numbers that multiply to give negative 6 but add to 3? No. It's not factorable, so I'm going to need to use the quadratic. A is equal to 2, B is equal to 3, C is equal to negative 3. And now I'll put that into my formula. X equals the opposite of 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 3. And I'll put that all over 2 times 2. Well, if I simplify, I get negative 3 plus or minus the square root of 9. Now minus, I'm going to add 4 times 2 times 3 because I have a minus and a minus. So I'm going to add 8 times 3 is 24. I'm going to add 24 here. And that's all over 4. 2 times 2 is 4. I'm going to continue to simplify. I get negative 3 plus or minus the square root of 33, and that's over 4. And that problem has been done. There's the two solutions. The square root of 33 cannot be simplified. It cannot be simplified. Okay. Number 13. Now, number 12 is very similar, and it is not factorable, so you'll need to use the quadratic. Okay, 13. Let's see if this is factorable. 2 and negative 3 is negative 6, and then negative 2 down here. So I'm going to see, are there two numbers that multiply to negative 6 but add to negative 2? And I'm not seeing any. So I'm going to need to use the quadratic equation. So x equals the opposite of b, well here, a equals 2, b equals negative 2, c equals negative 3. So the opposite of b is the opposite of negative 2, plus or minus the square root of b squared is negative 2 squared minus 4 times a, which is 2, and c, which is negative 3, all over 2 times 2. I went very quickly, so take a moment to see where everything was replaced for the quadratic formula. Or even better, try this before. You can try some of these before you watch the video. Try it first and then watch the video. Okay, so let's simplify. This is 2 plus or minus the square root of 4 minus a minus. This is going to be a plus. 4 times 2 is 8 times 3 is 24. So plus 24 all over 4. Okay, so this needs to be simplified. I get 2 plus or minus the square root of 28 over 4. Now remember, the square root of 28 can be simplified. The square root of 28 can be simplified. So I'm going to do that. The square root of 28 over here, I'm going to break that down to 4 times 7. And I can break that down to 2 times 2 times 7, right? I don't actually have to rewrite that. You can see the factors of 2 times 2 times 7. So the square root of 28, I can take out a 2, and what's left is the square root of 7. So I'm going to rewrite this as 2 plus or minus 2, the square root of 28 is equal to 2 times the square root of 7. It's been simplified. So now I rewrote it here, and that's all over 4. Well, I do need to simplify this a little bit more because there's a common factor of 2. So I divide everything by 2, and I get 1 plus or minus the square root of 7 over 2. Okay, number 16 is very similar to this, or excuse me, number 14 is very similar. You're going to end up with something that you're going to need to simplify a little bit. So practice using your quadratic and simplifying your terms at the end. In particular, your radical. Number 15, I'm going to check and see if I can factor that. Excuse me. And I get negative 3 on the top and 2 on the bottom. I could multiply 3 times a negative 1, and that would work for the diamond. So this is factorable. So instead of using the quadratic, I'm going to factor. And since this is a leading coefficient of 1, I can just take the factors directly from the diamond. X plus 3 times x minus 1 equals 0. Even better, excuse me, I can take the factors and set them each equal to 0 very quickly, and x here equals negative 3, and here x equals 1. And there's the two solutions. So now you check number 16 and see if it's factorable. Okay, number 17. We're missing a b term here, and so I can see if it's factorable. B will be 0, and a times c is negative 6. But there are not two numbers that multiply to be negative 6 but add to 0, so it's not solvable with the diamond. I'm going to have to use the quadratic equation. A is equal to 2, but there's no x term, so b is equal to 0, and c is equal to negative 3. So these are the values that I will put into the quadratic equation. X equals the opposite of 0 plus or minus the square root of 0 squared minus 4 times 2 times negative 3 all over 2 times 2. Now I'm going to simplify. The opposite of 0 is just 0, so it's plus or minus the square root of, well, 0 squared is this 0, so am I going to add or subtract 4 times 2 times 3? Well, that's 8 times 3 is 24, but I'm going to add it, so that's plus 24. And remember, the 0 doesn't need to be rewritten. 0 plus 24, all over 4. Now again, just 1 minute. Okay, again, I can simplify this radical. This can be rewritten as plus or minus. Well, how do we simplify the square root of 24? Break it down to its prime factors, 4 times 6, 2 times 2, 2 times 3. We have a pair of 2's, so 1 2 can come out. And what's left is 2 times 3, so that's 6. So the square root of 24 can be simplified to 2 rad 6. It's plus or minus 2 rad 6 over 4. Now this can be simplified a little bit further. 2 and 4 can be reduced, so it's square root of 6 plus or minus all over 2. I'm dividing this by 2 and this by 2, which becomes 1. So plus or minus 1 times square root of 6 over 2. And you try number 18. Okay, I'm going to stop the video, and then I'm going to do the second part with you in just a few minutes. This is part 1.